are at 90 degrees to each other. So if you have vector A and you got vector B and they are two different directions, then what you do is it's add the opposite is the rule. So vector A stays as it is, but vector B, the minus sign becomes a plus sign, and the arrow pointing downwards will point in the opposite direction, and then you just do your addition as you normally would do vector addition. And to find the size of the resultant, what you do is you just use Pythagoras theorem. Because they are vectors, you're often asked to calculate the angle, and usually the angle is where the tails meet. So it's this angle that you need to calculate, and you use any of your trig ratios, which can be cos or sine or tan, whatever you like, if you know all the three. Okay, now when you use the subtraction of vectors, they're used for either change in velocity or for change in momentum. And I put these little squiggles here for change in velocity and change in momentum. These little things indicate that direction is important. So don't forget direction, because when you subtract, you got to change the minus to a plus, and if it's an arrow pointing to the right, you've got to switch it to the left and then do vector addition. Now, just also a change in momentum is impulse, and so it's force multiplied by time is change in momentum, which is impulse, and questions on that could be conservation of the change in momentum. So for example, if you're doing a high jump and you say, like, what's the difference between landing on a soft mat at, this, you got your high jump pole and you're jumping and you're falling on something that's soft as opposed to hard ground. So what is the difference? So the difference is the soft mat, you take longer because it has got give, because it is soft. So you're taking a longer time to come to a stop. And if you take a longer time, then your force is less. If your force is less, that means there is less damage. So even though the change in momentum is the same, it does not matter how the momentum changes. However, taking a longer time will also mean that you're reducing the force and reducing the damage done. Now, the other thing that you have for mechanics is to do with projectile motion, and there are two possible types of questions in projectile motion. And as you can see, there is what we call half a projectile or the whole projectile. So this is half a projectile, where you could be asked either to find the height through which it falls or how far it falls from wherever it was thrown. So this is usually to do with objects that's thrown from a height, and whatever type of projectile motion it is, whether it is type 1 question, I rubbed it off by mistake, whether it is type 1 question or whether it is type 2 questions, no matter what it is, you always treat the horizontal and the vertical components separately. Okay, and then how do you find so for this half a projectile, it travels the whole way with constant horizontal velocity. However, the velocity at the top, so at the top of the projectile, is 0. Okay, and so that's the velocity at the top of the projectile. Because it's accelerating downwards, you've got to use your kinematic equation to find out if you want to find how long it takes to reach the bottom. So the velocity, initial velocity, is 0. Okay, and so there's your initial velocity, that's 0. You can use, depending on what's given, you can use any of your kinematic equation. So I just assumed the height through which it falls is 10 meters. Because it's falling down, I put -10. So I've just used d equals VIT plus half AT squared. But your A is negative. That is your acceleration due to gravity. But the negatives cancel. And you've got t squared. And then you find t by finding square root of this. And in order to find the range, that is how far does it fall horizontally, you need to use your constant horizontal velocity, which you will be given, and you find d equals v times t. As opposed to that, you can have a whole projectile, and you could be asked again to find the range, and you could be given the initial speed and the angle with which it goes. So the horizontal component is, I've just used 15, so it'll be 15 cos theta, because horizontal is your adjacent and you know the hypotenuse. This is your right angle triangle. Your vertical will be 15 sine theta, and it's quite good to separate the horizontal and vertical components so you don't mix them up. Okay, and you find, the first thing you need to find is the time taken to reach maximum height. You find the time, then you find the total time of flight by multiplying it by 2, and then you find the range, which is the horizontal distance, v equals d over t, but this v is your horizontal component of velocity. That's your 15 cos theta times 2 time, twice the time. Okay, and then you also have this little bit about forces, and some of the harder things that people find is the torques. Two types of questions on torques. You could have a torque question where there is only one pivot, okay, or you could have one with two support forces. And often the questions are draw all the forces acting on this thing. Wherever you have a support, you always have the force going up. But if the support is at the center, then the mass acts through the support. But if the support is not at the center, the mass of this beam will act through the center of the beam, which could be away from the pivot. Now, this particular example has them both at the same point. And then you have the downward forces due to gravity because of whatever is sitting on it. I've just drawn two cats, forgot the tail. Okay, just draw a tail for them and some whiskers. And these are their paws. Tail for the cat. Okay, they're both sitting there balancing each other. So torque is force times perpendicular distance, and your force is mg. So g is the same. So let's say this cat has a mass m1, that has a mass m2. This particular instance, the mass, the force of this beam itself has no effect because it's acting through the pivot. Okay, you could have it otherwise, but in this one, m1g times x1 equals m2g times x2. Okay, and the g cancels. You have to show the g and then show that it's cancelled, otherwise you get penalized for that. Some years they did. I don't know how it is going to be, but anyway, this is a good practice. So you end up with m1x1 equals m2x2, and usually there'll be one thing that's unknown. And this is the next part, your type 2 questions with two supports. Important thing, wherever you have your supports, your forces only act upwards. And let's say I've just got this one object sitting over here. Okay, there's something over here sitting. So all the forces is the two upward forces. There's nothing downward here, just upward. And the weight of this beam itself acts downwards from its center. And the weight of this one, the weight force, acts from wherever that's sitting. Now, in order to, suppose you have to find what are the support forces FA and FB, you need to take one of them, doesn't matter which one of them is the pivot. The thing is, whatever you choose as a pivot, all distances are measured from that point. Okay, all distances, and let's say we assume this whole thing is 2 meters, and this one acts right through the center. Sorry, that's my dog barking. And this one is about 1.5 meters. So at equilibrium, the sum of clockwise torques equals sum of anti-clockwise torque. So I've just gone mass, force times distance plus the force times distance. Figure out these are both clockwise torque. That is your anti-clockwise torque. So here's your clockwise torque. This one's clockwise, that one's clockwise, and this one is anti-clockwise. Okay, and that's equal to twice. That's distance times force. You solve that and you get your answer. And then in order to find out, so this is the answer for FB. And so what is FA? For total force upwards equals total force downwards. So the total force upwards is whatever is FA, we don't know, plus what we've just found out is with that one's 100 newtons and that one, this is 100 newtons and that one's 50 newtons. So that's 150 newtons downwards, and that's how you find this. And the very last thing in mechanics is to do with circular motion, which you have circular motion at constant speed, but it's accelerated motion. And because it's accelerated motion, you have to have an unbalanced force. your centripetal force, and this unbalanced force always acts at right angles to the instantaneous velocity, which is always a tangent to the circle, and the direction of acceleration is always the same as the direction of the unbalanced force. Your acceleration and unbalanced force, it's actually superposed, but I've just drawn them slightly separate. Here are your two equations for acceleration and centripetal force. If they don't give you velocity, then you can use velocity as distance over time, where the distance is the circumference of the circle, 2 pi r, and t is the time taken to go around the circle once. So if you're given that information, you can use this equation to find v, and then you can put it in your formula. And some sort of descriptive question where you have to say what happens is if there's an oil patch on the road, or if it's a ball being whirled around on a string, or if the string breaks, because this is what provides your centripetal force. So for a car going on a road, it's friction that provides centripetal force. So if there's oil, there's no more friction, so your centripetal force disappears. Okay, and therefore there's no unbalanced force. If there's no unbalanced force, it's not accelerating. And if it's not accelerating, balanced forces means the object will continue to move in a straight line at constant speed. This bit is important, the straight line and constant speed. And where is it going to move? At a tangent to the circle from the point where it breaks off. So if it is this one here, here's your tangent to the circle. Or if it's this point here, there's your tangent to the circle. So that's all for now.